Swayam Prabha. Digital India. Educated India.
Dear students, I am Dr. Shumana Gupta, Associate Professor in the Department of Architecture and Regional Planning, Indian Institute of Technology, Kharagpur. So, this course name is Fire Safety in Buildings. This course has been designed mostly for the architectural students and those who are mostly in the third, fourth year of their curriculum. Also, the civil engineers might find it important because they are also our associated with our subject and that can benefit them also. So, we will start with module 1. This course is a 10 module course and today we will start with the introductory module or the module 1. Coming to the contents of module 1, we have the need for the subject and introduction to the basic terminologies, the fire triangle, classes of fire, fire load, fire spread through conduction, convection, radiation, grading of buildings, classification of buildings based on occupancy. So, coming to the need for the subject, I would like to emphasize on particularly students who are from architecture. We cover the chapter of fire mostly through our design classes and also when we are learning the services part of a building. But gradually or day to day with urbanization and coming up of high rises, because of the cost of land, because of the densification of population, high rises and tall buildings where a lot of occupants are there, we are facing cases of fire. Yes, our fire departments are there in a city system who gives permission or the plan gets sanctioned and it is being executed. But most of the cases, in many of the cases, we see that they are also violated. So, one is the codes and standards part which we will cover in other module, but before entering to the subject, before entering to our domain, we need to know what is fire. So, we will start with the basics. It is rapid oxidation of any material and it is a exothermic chemical process. Exothermic means it gives out energy, gives out energy during the chemical process. It releases heat, smoke and light. So, here we see releases heat, smoke and light. Now, this heat is one which can destroy the building system, but smoke is something that can pass from one place to another without, you cannot stop it if it is not checked. So, fire also is associated, the deaths related to fire. Why we are considering fire? Fire is very useful, but fire at the same time can be a destruction, and with fire the smoke component is very another important subject which we need to know when we are considering our buildings, particularly buildings of large scale, institutional buildings, office buildings, commercial places, and we have to be aware of it. So, we have various design guidelines, codes, standards which are the passive part of preventing a fire destruction. With fire, another thing which comes into importance is the life safety, because that is of prime importance. One loss of life is very precious. So, we cannot afford to lose life. There may be victims who are under suffocation. So, that kind of safety we have to ensure. Other coming to the protection part, that is prevention, maybe through rules, bylaws, etc. Other part is the protection part from fire, like spreading the fire further. To protect it within the zone, we can install the active part. Now, Coming to the objectives of fire safety, we will get into the fire prevention, fire protection in our next lessons. The objective first is that protection of health and life safety. As I told you, every human life is important. Other than that, we have the firefighters entering into the system who are coming to rescue the people. So, their life is also of utmost safety to be considered. Protection of the property. See, a building comes with crores of rupees investment. So, protecting the building structure is very important. So, that means everything leads to you have to stop the fire. Protection of the contents of the building. A building can have lots of valuable documents, a building can have lots of valuable books, a building can have lots of valuable equipments other than human. It may have lots of valuable memorials. So, we have to be very careful on the protection part of the property. Also, a fire can affect the neighboring buildings, neighboring areas, the precinct, that also should be ensured. Protection against business interruption. So, it is very important to bring back the building to its original operation as soon as possible. So, one is protection of the property and putting the building to its use. That means, if it is a bank, to come back to its original use as quickly as possible should be the objective. And protection of public image. Obviously, if there are regular fires in one particular area, people become skeptic about the regulations over there, and yes, the city municipal authorities come for the safety purpose to save the people. The fire department comes into action. Protection of environment. With this huge the fire outbreak, with the smoke, it liberates a loss of effluents to the atmosphere. Lesser it is, better it is for our environment. So, these hazardous solids, the liquids, and as well as the gas which is being liberated because of a fire should be minimized. Protection of heritage values, as I in our introduction to the subject, I also mentioned that the heritage value, buildings may have lot of heritage value, it may be under our Archaeological Survey of India list and we need to protect it, and that is also one of the prime reasons for fire safety. Critical infrastructure like hospitals, like schools, like healthcare facilities, they should be all protected properly properly from fire, and they should be safe when they are under operation. Now, if we try to summarize, this is developed from the manual of fire safety. So, the purpose of fire safety can be purpose of the entire subject can be divided into two. One is fire safety, the other is life safety. Life safety is taking out the human component. So, design of egress, that means coming out, and through pressurization, which is an active method, ends the fire safety part. But fire safety that ends the life safety part. But coming to the fire safety, we see first we try to prevent it, it should not happen. But for that, what to do? If it is a hospital, it may be a hotel, it may be a domestic use. So, good housekeeping is important. Minimizing accumulation of combustible is important. Regular maintenance and overseeing what is happening by the building management is to be very much followed to prevent any case of fire. Materials are coming into importance. We as architects, we have building materials all around. So, we have to look what are the materials used, and yes, non-combustibles are to be considered. So, when we will go into the codes and standards, we will get into the materials part. Now, coming to the fire protection, as I told, there can be an passive part, there can be an active part. Passive part can be through compartmentation, fire resistant materials, fire resistant structure, whereas the active part is embedding various systems into the building. It may be fire extinguisher, fire detector, fire venting, and that has further subdivides or branch, like fire extinguishing may be manual, may be automatic. We have the sprinkler systems hosted in various places like banks, institutions, schools, hostels, where even through a fire drill, the people who are living within it gets oriented to use the handheld fire extinguishing systems to extinguish fires. So, those are the manual extinguishers or the hydrant systems, while when you pull down a switch, the fire sprinklers become active. So, or other is automatic, where the automatic sprinkler system can work or automatic flooring system can work. So, we will get into the detail of each in the further modules, and one other is the fire detection, which can also be, as I told, when it is automatic or it may be manual, and fire venting can also be done under the active systems. Now, coming to why fire. So, fire can happen, there can be a lot of extinguishable items in a house, in a building, but there should be some source or spark to ignite it, and to continue that ignition there should be some oxygen supply. So, unless the three, that is the fuel, the heat and the air is there, without any one of them the fire will not happen. So, there may be lot of combustible thing within a space, there may not be any fire. There may be lot of sources of heat, but it is not coming in contact of the fuel, like in a kitchen we heat and use the heat for cooking. Unless there is a combustible item, that heat will not do any harm. Unless there is sufficient supply of oxygen, there will be no further or development of the fire. So, these three items form the fire triangle. But nowadays another concept has come, which is the fire tetrahedron, where there is another component apart from these three, where it is told that there are a chain of reactions which inhibits fire when this fuel, heat and air is burning. The chain reactions happening during that is also forming another layer, which is helping in the process, and then it is called a fire tetrahedron. So, it refers to the fourth phase refers to the chain reactions happening while the fuel is burning. So, what are the sources of oxygen? It is the air. We need 16% of atmospheric air for burning. Coming to the gases, coming to the fuel, it may be solids, which we are more concerned about. Liquids, yes, the hazardous part, the gasolines, the petrol, but in building cases it may be paints also, varnishes, which are the liquid kind of fuel, and gases, as you see, hydrogen gas, carbon monoxide gas, etc., they can be very much considered as fuel, and they are much more vulnerable. The fire from these kind of gases or these liquids are much more vulnerable than the solids. In case of buildings, we have our bricks, our concrete, we have wood, we have paints, we have lot of combustible items inside like the chairs, tables, etc. So, which also come under the solids. Coming to the heat, so heat source, it may be the sun. If you have a facade which is concave in nature and the solar heat, solar radiation can lead to a fire. I think if you can recall some cases of car burning from solar radiation from glass panels has happened in our urban scape. So, any hot surface, any sparks, any welding happening in and around, any chemical action, even friction can lead to any fire or can be the source of heat. Electrical energy, yes, compressed gas, all these can become very important sources of heat and fire. Now, let us move to the next, which is the classes of fire. If you see the list here, enclosure fire, pool fire, pipeline, oil pipeline fire, LPG cylinder fire, and the last one is the forest fire. Now, yes, forest fire is also a fire which is not coming under our purview, but this leads to lot of environmental losses. But we are mostly into the enclosure fire. Yes, pool fire happens if there is a pool of oil spillage and there is a fire. Oil pipeline fire, when these happen on sites where, say, like ONGC bringing oil from one point to the other, in their case some leakage can lead to pipeline fire. LPG cylinder fire can happen in the house, in a domestic level also. So, if you see under the 5 classifications, A, which is ordinary combustibles, which we usually face in a building context, B, which is flammable liquids, that is from petrol or diesel, etc. Like you see gasoline, kerosene, propane, paints, solvents, such kind of fire. C, which is live electrical equipment fire. So, hazards can happen, fire hazards can happen from various electrical equipments, charging points. D is combustible metal. You can see a I section drawn over here. So, this is a steel section which is combustible metal. They actually deflect and that can lead to fire, that can lead to failure of a building. K, or the last one, is commercial cooking equipment, that is happening from vegetable oil, cooking oil, animal fat. When you are doing some cooking in a pan, suddenly the fire can, the oil can get set into fire. So, such kind of things can happen in large scale kitchens, and one has to be very we have to put extinguisher, handheld extinguisher over there. So, this is again another kind of fire where commercial cooking equipment can lead to such kind of fire. So, we will be finding mostly our fire will be ordinary combustible one, live electrical equipment and cooking fire. Yes, we have combustible metals where we can see that our building structures, which are, if they are made of exposed steel, they can get into this D class of fire. Now, let us come to the stages of fire, stages of a fire development. So, what happens if we just light a match? Initially, it just gets started, it grows because there is a wood stick, it grows, and because there is a very little fuel which is the wood, it immediately within few seconds it stops. So, within a small matchstick also there are the stages visible. You see, for a considerably large scale, which is at a building scale, not like a match, you see 5 to 10 minutes, 20 minutes is the first stage where a spark is required spark with required energy density or heat, that was one of the triangle, generated to one of the side of the triangle, or heat generated to reach the ignition temperature. So, you are igniting the fuel and it may take up to 5 to 20 minutes to create a fire of a considerable amount when it is termed as a full growth, which is termed as a case of fire. Now, coming to the second stage is the growth period, when in the next few minutes the fire starts growing, because it is a gradual process to reach to the full development, that means full burning of the fuel. So, from this growth, gradual growth, suddenly in no time it goes to a full curve. So, you see here it is a S kind of curve forming in a very short period of time, and the burning continues for another 20 to 40 minutes depending on the fuel size obviously, and during this full growth period a lot of things can happen. So, this flashover period is very important and the fuel continues burning, and by this time, by this stage actually the people need to be taken out of the building. That is the principle. We will go to that in details later on. And further what happens post flashover, that means the gradually after the full development and the burning of the fuel, the decay starts. Now, this is we are talking of one fuel, but if one fuel moves to another fuel, this another curve again starts from here and continues here and continues, and the fire continues. So, this is when lot of risk comes into play, and we need to actually stop the fire at any of these points, these zones. Just by knowing with the increase in temperature, the systems should come into place if it is a active system. The passive system should stop it further growing. So, now coming to the written part, not all fires follow this development. Some fires may extinguish naturally or may not reach the flashover. So, at the very first, in the inception stage, if you can stop it, that is the best. Too much heat may flow out because of large windows. So, that can be insufficient supply of oxygen. So, the combustion may stop. So, if the room has very large window openings, too much heat may flow out and there may not be a flashover. So, you have to have the heat accumulated to go for a flashover. So, this is how in 4 stages the fire development happens. So, it is the inception stage, the flashover stage, the full development stage, the 4th stage is the decay stage. If things happen continuously, the flashover adds up and the full development time increases, zone increases, but for every building system there is an alert system, there is individual observers, and the things can be taken under control. So, if we see the fire behavior, heating of the fuel, fuel controlled burning, ventilation controlled burning, fuel controlled burning is again the decay period. So, we have put in the 4 stages for that is the fire behavior. What happens to the human being? They will try to prevent the ignition, extinguish it by hand. They cannot do, they will start escaping. If they cannot get escaped during the burning period, it may lead to death. So, here comes during the growth period, one has to escape, but you cannot leave the fire just like that and escape. So, people as per the human behavior, they will try to prevent the starting, prevent the fire to grow further, but if it is out of control, they will try to escape. If they cannot escape, the next stage during the burning period, they might end their lives there. Detection. Smoke detectors can detect that there is a fire. Smoke detectors, heat detectors during the growth period can also find out. During the burning period, there can be external smoke and flame visible. So, how to detect the fire? One is smoke detectors can detect and set the alarm. If the building do not have such system, then we have to go till the burning period when the external smoke and the flame is visible to the people and people understand there is a fire going on. Active control prevent ignition. They will not even allow you to go till that stage. Extinguish by sprinklers when if it is detected when it is at the if the active control detects at the growth period, they will start the sprinkler system and will try to control the smoke. Control burning period, the firefighters has to set in apart from the control. Passive control, we can control the building materials, we can have a control on the materials, we have control on the usage of the materials, we can have a control through our building management system. Select materials with resistant to fire flame spread. So, growth period can be deferred. Provide resistance to contain the fire and prevent collapse. So, materials are there which will not allow to reach the burning point. So, we can select materials from the codes and standards if the spaces are can experience fire in any point of time, like there can be a kitchen, there can be a computer laboratory, there can be gases entering like the operation theatre. So, various spaces will come under our purview where we will need to use or provide material control through passive, active control, various fire control mechanisms through the active systems. Now, coming to another concept, we can keep on telling or discussing things, but how to put it under a measurable quantity. Say within a house, within a bedroom, let me start with a very small domestic plan which is a bedroom. There can be a bed, there can be pillows, there can be cushions, there can be dress material, there can be books, there can be such items. So, each of these items have some calorific value, and say the cushions altogether may have a weight, say 2 kilos, 3 kilos. So, if these pillows are set to burn by some small spark, these will burn with its calorific value, and that will lead to further burning maybe of the mattress, maybe of the books in the shelf, and it will gradually grow. So, the starting point we have the combustible material, that is the fuel. So, fuel weight in kg and into its calorific value divided by the total floor area, because the materials are within a space, will be considered as the fire load energy density. If you see here, fire load energy density, which is also called as FLED. So, it is per unit area in meter square, because space mostly meter square. The amount of combustible material into its calorific value, you see weight of the combustible material in kg, calorific value in kg per in kilocalorie per kg, and the floor area in meter square. When summation of all these weights are multiplied with their individual calorific value and divided by the total floor area, it is defined as the fire load energy density. This value, more it is, greater is the content of fuel in one term and in higher are the chances of its damage in case of a fire. So, if we look into the very small problem over here, calculate the fire load for a fire in a warehouse. Now, you see it is a warehouse where not much of human being is there, with a floor area of 300 meter square, containing 2000 kg of propane liquid whose calorific value is given, and 800 kg of bitumen whose calorific value is given. The solution is given over there. So, if we go by the formula, what will happen? The area of the floor is 300 meter square. One was propane, one was propane liquid, other was bitumen. Propane, other was bitumen. So, one is 800 kg, one is 2000 kg, other is 2000 kg, other is 800 kg. So, you multiply with their kg, you multiply with their calorific value, you get the amount, you get the amount of combustible material into its calorific value. So, mass of propane into calorific value, mass of bitumen into calorific value together is 119520 into 10 to the power 6. 119520 into 10 to the power 6. So, this into 46.4 into 10 to the power 3, 33.4 into 10, 46.4 and 33, 46.4 into 10 to the power 3, this is 33.4 into 10 to the power 3 into 800 into 2000 will give you this value, that is kg that is kg kilojoule per kg, that will be in kilojoule, kilojoule, and then we are going to the fire load energy density will be total heat generated divided by the floor area. So, we have to divide this value by 300 to get the fire load energy density, which will come in again in joule per meter square, because this comes converted into joule per meter square, and then it is converted into kilocalorie per meter square by considering 1 kilocalorie as 4.184 joule. So, this value fire load energy density is in joule per meter square, this is 398400 kilojoule per meter square, which is equivalent to 95311 kilocalorie per meter square. So, what is the conversion? 1 calorie is equal to 4.184 joule. With this, you can find out the fire load energy density. Now, this is a very important metric to measure the building hazard standard. So, obviously, higher it is, hazardous it is. So, this fire load determines how much of fire can happen if this building is of this kind. So, that helps you in giving a list. There are ranges where IS 1641 of 1960 divides the fire load into 3 categories with corresponding occupants. Sometimes we use international codes also, but here you see low, fire load is low means risk is low. Fire low is moderate means risk is moderate. So, if it is anything between 2.75 into 10 to the power 5 calories kilocalories per meter square, it is low. And which of the houses come under that, which of the properties come under that? Residential building, hotel, boarding houses, restaurants, schools, hospitals, places of worship like temples, mosques, churches. Which are coming under moderate? The retail, shops, markets, shopping malls, emporiums, factories, workshops. But try to remember one point, each of the floor you are calculating. If it is a high rise building, it is a residential building, fine. It is a hotel building, fine. But if this hotel is multi-storied, it gets multiplied. Each FLED multiplies by 20 number of floors, 50 number of floors, and that is why these residential buildings are becoming more and more important for safety. Hotels are becoming important under safety, hospitals are becoming important under safety. So, yes, if you can calculate out the entire load and then classify them, then it becomes you can understand that not only per meter square is the total, but the entire building has lot of potential if it is set to burn. Moderate, we see retail shop, market, shopping malls. Why are they coming under moderate? There are shopping malls have stacks of items within them. It may be merchandise, it may be oil, it may be, so a departmental store can have various kinds of things which are combustible. And under high, you see it is the go down, warehouse, buildings where bulk storage, non hazardous, petrol pumps, all these come under high risks. And you can see the last line here, buildings with fire load of more than 4.6 into 10 to the power 6 kilojoule per meter square or 11 into 10 to the power 5 kilocalorie per meter square are considered unfit for occupancy. So, as an architect, are we going to multiply and find out what is it? No, we have to look into the codes and find out which kind of building comes under what, because such things have been done at the back of the document being prepared and they are listed likewise. You see calorific values of some common materials taken from the National Building Code. Because the calorific value is discussed here. So, this list is provided over here, it is taken from the National Building Code. So, also the wood equivalent is also given. So, wood equivalent, if you see wood as an item, it is there somewhere, yeah. Wood as an item, if you see, because we use wood in a building, wood is considered as 1. It was in the list. Wood is, yes, wood hard or soft, whatever it is considered as 1. So, wood equivalent is considered, that wood is considered as the unit and wood is considered as 1 kg wood burning equivalent is equivalent to burning of 1.7 kg of wood. Bituminous coal is 1 kg of bituminous coal burning is equivalent to 1.75 kg of wood burning. I hope you understood that. Now, other criteria of the combustible materials, we are looking into the combustible part. Other is how quickly a material burns, ease of ignition, like how quickly it will start burning. Then is how, in what speed it will continue burning, and then liberation of heat and fumes, what is the characteristic while it is burning. So, not only the calorific value, but the ease of ignition, how quickly it can take fire, how quickly it will, how speedily it will be starting the burning process, and how the heat and the fumes will be liberated, that means the gases or the smoke will be liberated, is also important, or is also are also the other criteria of the combustible material, not only its calorific value. So, those can be again measured through the heat release rate, which is called as HRR, which is again a list of values, which is kilowatt per meter square, measures the flammability of the item. We call a material is flammable, inflammable. So, measures the flammability through the heat release rate. Smoke mass flow rate, that is in kg per second. What was that? Liberation of heat and fumes. So, the measures mass of the smoke that is liberated. So, that is coming in kg per second, how much of smoke is being liberated from the material. So, these are various indexes to measure the speed of burning, liberation of heat and fumes, which are the other characteristics other than the calorific value. I hope you are getting oriented to what is fire, how it is, how to measure it to some extent, in case of buildings how we should consider it. Now, if we come to the occupancy, as we talked about the occupancy beyond a certain calorific value of a building, we do not consider it as safe for building occupancy. We have, as per NBC, we have various categories of buildings. Residential buildings more than 15 meters will be considered for will need fire safety certificate. Hotels, as I told, these are having low calorific value, low FLED, but yes, beyond a certain height they are to be considered under the fire safety certification. Educational institutes, see, more than 9 meters it will come under fire safety certification. Business, more than 9 meters it needs to be passed by a fire body of within a city, which will give the certificate, fire department. Mercantile building more than 9 meters or G+2, that means 3-story building or 9 meters, whichever has to be certified by a fire safety department to start its building. Industrial building and storage buildings, there is no height cap. All buildings beyond 250 square meter, be it ground floor, be it 2 floors, it has to, if it is more than 250 square meters, it has to get a fire safety certificate. All assembly buildings, invariably of its floor area or its height, needs a fire safety certificate, because it may be a ground floor, it may be a small place, but if there is a fire, it is an assembly building, that means people will be coming. So, fire safety from the occupants, that means the users who will be using the building off and on, should be safe. So, it does not allow any building without a safety certificate under that category. All hazardous building more than 100 square meters need a fire safety certificate. So, see, all assembly buildings could be a multipurpose hall. It may be by 100 meter square can be an assembly building, it may be a multipurpose hall. So, it needs a fire safety certificate. So, these are the mandates given in the National Building Code since long, and these are to be acquired. The safety certificate has to be acquired not only depending on if it is a low calorific value building or not, it may be either guided by its height or by its floor area, or maybe both, or only by the usage. So, depending on the uses, the height and the floor area, we need to apply for the fire safety certificate, and this brings in the integration of fire safety as a subject into the architectural design process. Now, coming to the three methods how fire can move. So, we have understood the calorific value, what is the calorific value, how a fire can fire, the heat release rate and the smoke spread index. So, these things will help one to understand the material property. Now, how the fire can move from one place to another. As I was telling, a flashover can lead to another flashover, can lead to another fire, can burn another next substance. So, the three mechanisms, because you all have studied science at some point of your education, conduction, convection and radiation are the three ways. So, conduction is transfer by direct contact of the affected surface with another surface. So, you are conducting heat from one material to another material through another material and it is getting to the next place. Convection is the transfer of heat through the molecular motion of air or water or any fluid. Convection current happens within when you are boiling water. It is the convection current taking the water from the lower to the upper and the current flows. And radiation, as I told you, sun is up there, but if you can focus the sun through a magnifying glass, you can burn a paper. Very simple example which you have done in science. So, you are not bringing the sun, you are not bringing the source, but you are only concentrating the heat and burning a paper. So, it is the solar radiation which is doing that. So, from a heat generated at a point, the radiated heat can lead to another fire. So, this happens if there is a huge fire outbreak at one building, it may lead to a fire outbreak in the next building facade. So, buildings can get affected, the neighboring buildings can get affected by fire from one to the other. You if I give you references like slums, it may happen in one slum, but because the next slum is very close and the items are very quickly ignitable, ease of ignition is very high because it may be straw board, it may be straw, it will immediately catch fire and one after the other the slum can get affected by the fire. So, that is what is radiation. So, conduction, convection, radiation are the three ways where the fire can spread. Why are we doing so? You can see the conduction, there is a barrier. So, if we want to put a barrier, the barrier to help fire from moving from one space to another space, because we architects understand space, a bedroom to another bedroom, a classroom to another classroom, a clinic to another clinic. So, if the barrier in between, that is defining the two spaces, is allowing the heat to transfer from one space to the other, the fire will spread. To contain the fire is the key or the success to save a building most. Coming to grading of buildings according to fire hazard, fire safety of buildings and corresponding protection shall be considered. We consider personal hazard, we consider internal hazard, we consider exposure hazard when we talk of conduction, convection and radiation. Personal hazard, possibility of loss or damage of life, it requires provision of liberally designed and safe fireproof exit in all buildings, particularly those having more than one story. In ground level, people can escape very easily. So, grading of building according to fire hazard, we need to look into personal hazard, we need to look into internal hazard. What is that? Possibility of fire occurring and spreading inside the building itself concerns damage, destruction of building and influences personal hazard directly. It is directly related to the fire load of the building. Now, you can understand these definitions. Exposure hazard, possibility of fire spreading from an adjoining building or from across the street or road. It deals with the risk of fire spreading through the open air, which is radiation, into the compartment of a building through open air, that is through convection, from a fire in another compartment of the same building. It does not include the risk of fire entering a building or a compartment within directly through wall, floor or through vertical shaft or staircase. So, that is what is exposure hazard. With all these, I would like to thank you all for your patient hearing, and we now would close the module 1. We will open with the next module, module 2 in the next class.